Greetings and welcome. In this section, I'm going to explain on how to tackle questions on quadratic sequences. This is one of the type of sequences that you'll find that always come in the exam. So I'm going to explain and make it easy for you. I've taught students for quite a while now, many years, and I've seen that most students, they somehow struggle on handling questions on quadratic sequences. We know that we have got three types of sequences. Okay, I'll list them here. The first one is arithmetic sequence. Okay, we are not going to get into that arithmetic sequence. By this time, I hope you understand what a sequence is. If you follow some of the videos that I've posted, I've explained what a sequence is. A sequence is simply a list of numbers where the order of the numbers is important. So these are numbers that are listed following a particular order. So we have what is called arithmetic sequence. Usually it is shortened to AS. And we have got a geometric sequence. Okay. And we have got, this is shortened to GS. And then we have got the quadratic sequence. We have a quadratic sequence. Okay, no particular abbreviation for it. You can call it QS if you want. So we are going to, I'm going to explain the background of how do you tackle questions on quadratic sequences. I'll give examples of questions from the previous exam questions that have appeared and how you will answer those questions. Now let's come to the definition first. What is a quadratic sequence? Definition. Now, a quadratic sequence is a sequence in which the second difference is constant. Okay. A quadratic sequence. I will explain that in a while. A quadratic sequence is a sequence, which means the order of numbers here is such that is a sequence in which the second difference is constant. Okay, let me highlight that. So the second difference is constant. What do we mean by that? So let me give an example here, e.g. I have numbers 4, 11, 22, and 37. Okay, and so on. They can continue. Now, when you look at these numbers, you'll find that they are not arithmetic. It's not an arithmetic sequence. An arithmetic sequence is a sequence in which we are adding a constant value. We are adding the same number. So if you take from 4 to 11, we are adding a 7 here. But from 11 to 22, we are adding a different term. So it's not arithmetic sequence, and it's not geometric. We are not multiplying by a constant term. So what this statement means that when we subtract these numbers, we know that this first term in sequences, we call it T1, and the second term is T2, which is term 2 or second term, and this is third term and fourth term. So when we subtract the terms T2 minus T1, okay, so we usually present our working like that. So meaning 11 minus 4, we get a 7. We write our difference here, the difference between 11 and 4, T2 minus T1. Okay, we also repeat the same process here. 22 subtract 11, we will get the number 11. 37 subtract 22, okay, what do we get there? We get 14. Okay, so get, actually it's uh, 15 rather. Okay, must refresh my additions and subtraction. Okay, so that is 15. 37 minus 22. We can go on and on, but for now we have got these four terms. Okay, now this row of numbers that we have written here, our differences, we call that one the first difference. So this is a row of first differences, which means this is a set of numbers that we got after separating the first time. So it's the first differences. Now, when we repeat this process, we subtract again. We are going to take the 11, subtract 7, okay, we'll get a 4. 15 subtract 11, we'll get 4. Okay, so now we have a row of second difference. So this 4, 4 is second difference. We refer to that as the second difference. So what we notice here is our first differences, they are changing. It was 7, 11, 15, but now our second difference remains the same. It's not changing. It's 4, 4. Okay. So when we continue, you find that all the numbers that we list under the second difference row is constant. It doesn't change. So such a pattern or such a sequence is what we call a quadratic sequence. We can take another sequence. Let's take another example. Okay, another example that we can take is 5. Let's take 5. We've got 5, 16, 33, 56. Okay, so we'll list 4 terms here. You can go on. If you can guess the next number here, it's fine, but let's deal with these 4. Okay, so when we subtract 16 minus that one, we will get 11. 33 minus 16, we just present it like that one, we will get that is 17. Okay, and the 56 minus 33, okay, we'll get it 23. So that is 23. We can go on and on. Okay, so we now have our first differences here. Okay, this is our row of first difference. Okay, first differences. And then when we repeat the process, let's repeat. In other words, we are going to take 17 minus 11, we'll get 6. Okay, 23 minus 17, we'll get 6. Okay, so we now have a row of second differences. These are our second differences. So our second difference is constant, it's not changing, it is the same. So that sequence is an a quadratic sequence. Okay, so there are many examples that we can give, but that's how you define a quadratic sequence. So how do you handle such questions? So you'll find that different from arithmetic sequence, it's not very obvious to be able to come up with, to create, to write the list of numbers that will come in here, which we call terms. Okay, so you have to follow a specific way of calculating how you can find the terms in our quadratic sequence. Okay, so that's the definition of a quadratic sequence. Now let us get into one of the most important principles that we need to take note here. Now, the general term of a quadratic, when we are working with sequences, be it arithmetic, be it geometric, be it quadratic, okay, so I will have here general terms, okay. For arithmetic sequence, I'm just giving us a background. We know that the general term is given by Tn is equal to A plus n minus 1 d, okay. And for geometric sequence, our general term is A r to the power n minus 1, okay. So that is the general term for geometric. We are not going into that one. I'm just summarizing here. Now for quadratic sequence, which we are going to get into now, quadratic sequence. For quadratic sequence, let me write the term here. For a quadratic sequence, the general term is given by Tn is equal to an squared plus bn plus c. Okay, so this is what we are going to focus on in this tutorial. We know that Tn refers to the term in nth position, okay. So a general formula or the general term is a formula that we use to generate all the terms in a sequence. For example, here, coming back to the question here, right, we have got these terms 5, 16, 33, 56. Okay, those are our terms. Now, if we were to find an equation that we are going to use to generate, to create those numbers, what would be that equation? So that's what we call a general term. Okay, so as you can see here, our general term is a quadratic. It has got a quadratic format. It's in the form of a quadratic expression. Okay, A, B, and C, those ones are numbers. They are just numbers, okay, constants. And our main task, as we are going to explain in this tutorial, is to find out how can we find those terms. N refers to the position of a term. So remember, terms in a sequence are defined by their position. So if I come back to this, this is a quadratic term, -5, okay, 4, 23, 52, and so on. These are called terms. These are called terms. Each term has a position. Okay. Here our n is 1. Here our n is 2. Here our n is 3. So these terms are described according to their position. According to their position. So if we are going to find T4, okay, this means the term on position 4. So you'll find that the general term uses the positions, okay. So to find the T4, you have to find a number A that you multiply by the position squared plus another number multiplied by the position plus a constant. So that is the format of a quadratic sequence. So we call this one the general term of a quadratic sequence. So now what we have to do is now we want to generalize our terms here. Now, when we take our terms, let's say we have T1, okay, which means term 1 and term 2, and I'm spacing them out now because we are going to write something important here, term 3 and term 4. You'll find that most of the sequences that I've written here, there are 4 terms, 1, 2, 3, 4, 1, 2, 3, they are in 4s. The minimum is 4. Why? Because we want a situation where when we separate first, when we get our first differences, you've got 3 numbers, and then the last row should have a minimum of 2 values because we want to compare. So if we list 3 terms, you will find that when we divide, as we divide, I will end up having 1 terms, of which we won't be able to compare, okay, to see is it remaining the same. So we are going to list the terms here, T1, T2, T3, T4. So what we are going to do is to find for every quadratic sequence, what would be the first term? What would be T1? What would be T1? So what we do is we are going to substitute here in our expression, substitute n with 1, okay? So we are going to say T1, let me write it here, T1 will be equal to a number a times 1 squared, okay, because our position is 1, plus b times position 1 plus c. Okay, so when we simplify this, you find that our T1 will be 1 squared plus a, that will be a plus b plus c. Okay, T1 is that. So what does that tell us? It tells us that for every quadratic sequence, the first term is always the sum of these constant terms, a plus b plus c. Okay, every quadratic sequence, the first term is a plus b plus c. So I can write here under T1 that the first term is always an a plus a b plus a c. Okay, now if we are going to find T2, let's find T2 in the same manner. So T2 would be, now 2 means the position is 2, so we substitute here the 2. So we're going to have a times 2 squared plus b times 2 plus c. Okay, we are substituting in our general quadratic expression here. So when we simplify this, this will give us 2 squared by that one, that is 4a plus 2b plus a c. So it means the second term is always a 4a plus 2b plus a c. Okay, for every type of quadratic sequence. Coming to the third term, if you continue with third term, so our T3, so the term on position 3, in general, it will be a times 3 squared, so that will be 9a, okay, plus a times b, 3 times b, that will be plus 3b plus a c, okay. And the fourth term, if you follow, you can see a pattern here. This is 1 squared, 2 squared, 3 squared. This one is a 4 squared, which is 16a plus our constants for 3, they are going 1b, 2b, 3b. So this one will be a 4b plus c. Okay, so that's what we have here. So let me just clear off here. So we are saying that every quadratic expression or terms sequence, it takes that format, right? If I'm going to use this one as my example, so which means the -5 here, this number a plus b plus 5, this will be our -5. So this will be -5, and this one will be our 4. Okay, this will be our 4, and this one would be our 23, and this one would be our 52. Okay, so term 1, term 2, term 3, so this is the same for every sequence, but here we can change the values. Now let's apply the subtractions that we were doing here. Let's apply this format, what we have been doing here. So let's subtract now our terms like we have been doing. Okay, now I'm going to subtract the T1 from the T2. In other words, the T2 minus T1. Okay, let's subtract. I'm going to subtract the terms here. So if I take this and that and subtract, I'm going to have 4a subtract a, that will give me 3a. Okay, 2b subtract b, that will be b, that will be 3a plus b, and the c subtract c, that will give us a nothing. Okay, 0. So we are now creating our row of first differences. Let's subtract again. Okay, when we subtract here, so 9a plus 3b plus c, subtract that one, we subtract like terms. 9a subtract 4a, we get 5a. Okay, 3b subtract 2b, we get b. Okay, c subtract c, that is 0. Okay, we subtract over here. Okay, 16a subtract 9a, that will be 7a. 4b subtract 3b, that will be b. C subtract c, nothing. Okay, so you will see these numbers, they are going in odd numbers. 3a plus b, 5a plus b, 7a. So your guess is as good as mine that this will be a 9a plus b if we continue writing the terms here. Okay, so now, so this row of numbers that we got here is our first differences. Okay, this is our first differences. So let's see, label it as such. So these are our first differences. Now the numbers that we got after subtracting the first time. Okay, if we are going to particularize this one, we are going to say 4 subtract 5. So when we take our terms in the sequence, 4 subtract 5, this is a 9. Okay, so that will be 4 subtract 5, that will be 9. 23 subtract 4, that will be a 19. Okay, and 52 subtract 23, that will be a 29. Okay, so now the 7a plus 2b is representing this number 29. Okay, I hope you are following me there. Okay, so our row of first differences are 9, 19, 29, but when we generalize that, it will be 3a plus b, 5a plus b. So take note of these numbers, because those are the terms that we are going to use when we express, when we are going to solve questions. We will get into the examples very soon. Now, so we've got our row of first differences. Now let's come to the second differences. Once more, I'm going to subtract the same terms, these terms now, the general terms. 5a subtract 3a, that is a 2a. Okay, b subtract b, there's nothing there, and then we subtract again. Okay, 7a subtract 2a, 5a, that is a 2a. B subtract b. So now you will see that our row of second differences, these are our second differences. Our second differences are constant. It's always a 2a. So our second differences, the second difference is constant. Okay, so if we were to use this sequence that we are using here, that would be a 19 subtract a 9, that would be a 10. Okay, 29 subtract 19, that will be a 10. Okay, so we have a row of second differences and it is constant. Okay, so we are going to use this pattern or these expressions now to help us to solve some questions. So the question would be, determine the general term of the quadratic sequence. So I'll put it down here like this. Okay, so let's write the numbers. I'm now going to write the numbers here: -5, 4, 23, 52, -5, 4, 23, 52, and so on. Now we want to find the general term of this sequence. This is a quadratic sequence. So what we do is we follow the format that we have done here. Let's find our first differences. Okay, so we have done that already. Okay, 4 subtract -9 and -5, that is a 9. Okay, we do that again. That will be 23 subtract 4, that will be 19. And 52 subtract 23, that will be 29. Okay, let's subtract again. We get 10 and we get 10. Okay, so this is standard what we will have to do if we are going to find the general term of the sequence. Now what do we do now? We want to find the general term. Our general term is given by Tn is equal to an squared plus bn plus c. Okay, n is representing the position, so we want to use the position to find our terms. So what we do is a, b, and c is what we are going to find. As you will notice here, okay, this term here, 10, that we have got here, the 10, it's always equal to 2a. So we can say that the second difference is always 2a. It's a 2a. Okay, so that is the most important part now. Okay, the second difference is always twice the value of a being the coefficient of the square of squared term, or coefficient of n squared. Okay, now we are extracting this now. We are extracting this from what we have done here. Okay, now when we come to 9, this first term here in our first difference is this 9. This 9 here, we said it is equivalent to 3a plus b. So this we can write it as 3a plus b. So our 3a plus b is a 9. Okay, this -5 here that we got, as you will see here, this is equal to a plus b plus c. So this is an a plus B plus C. So our A plus B plus C is negative 5. Okay, our 3A plus B is equal to 9, and 2A is equal to 10. Take note of these terms because we are going to use them in finding the general term of the sequence. Okay, take note that here we are using this row of numbers, negative 5, 9, and 10. We are not using 19, and we are not using 4. Now, if you take 19, you will not equate it to 3A plus B. Our 19 is 5A plus B. So you can use that. So if you're going to use this row here, okay, that will be 5A plus B. Your 5A plus B will be a 19, okay? And your 4, which means the second term, it will be a 4A plus 2B plus C. So take note that we are focusing on the first row of our numbers here. Okay. So now these rows, these terms that we have written here, A plus B plus C is equal to that, 3A plus B is what we use to solve. So we are going to work simultaneously upward. We are going to work from the bottom upward. So we want to find our A. So where do we go now? I would start by saying 2A is 10. Okay. In most cases, we say that A is half of the first difference. So A is half of 10. So which means if you solve here, 2A is equal to 10. So our A is 5. Okay, we get it from that statement there. We are going to work simultaneously now. Okay, working upward. So after getting A, we go to the next step here, 3A plus B. So write again, 3A plus B is equal to 9. Okay. And our A, we got it is 5. So it's going to be 3 times 5 plus B is equal to 9. This is going to give us 15 plus B is equal to 9. That gives us B being equal to negative 6. 9 minus 15. Okay, we continue. Now we got our A, we got our B. Now we'll go upward to A plus B plus C. So we are going to say A plus B plus C is negative 5. Okay, our A, we got it is 5. Our B is negative 6 plus C, we get a negative 5. That gives us, okay, 5 minus 1, that will give us negative 1. Take it there, that will be negative 4. So our C will be equal to a negative 4. So we got our A, B, and C, which means we can write our Tn. Therefore, our Tn is going to be A5 n squared. We are now writing down the values of A, B, and C. Okay, minus 6n minus 4. Okay, so that gives us the general term. So the expression that we got here is our general term. Our general term. So take note here, when we are equating these terms, 2A is equal to 10, 3A plus B is equal, we are taking the first terms in our rows. So this first row, this is our second row, this is our third row. Okay, our second difference, first difference, and the terms themselves that are in the sequence. So now we take note that we are not equating to 19. Okay, we are taking the first term, which is a 9. So 3A plus B is equal to 9. Don't equate it to 19. If you want to use 19, let's go back to our diagram here. 19 you would equate it to 5a plus b. Okay, I hope you are with me there. So if you are going to use 29, 29 will be a 7a plus b. So in this case, we are using this row here. Okay, that is the row that we are using. If you are going to use this row of terms, so your 2a will remain a 10, but your 5a plus b will be 19, and the second term will be a 4a plus 2b plus c. Okay, we are just taking this one, okay, as a standard measure for us to be able to calculate that. So take note of that. So if you are going to use 19 and this one, our expression would change, okay, to 5a plus b, and so on and so on. So now coming back to this term, what does this general term mean? Okay, the general term, like I explained earlier, it means that this is the formula that we are using to generate our numbers, our terms. So we see that our terms here are, okay, they're over here. Our terms are -5, 4, 23, 52. So in other words, let us use this general term to create those terms now. So let's say we want to find T1. Okay, we want to find T1. So T1 is the first term. Okay, so meaning that our n is 1. So we are going to substitute 5 into 1 squared minus 6 times 1, okay, minus 4. Okay, simplify that one. That will give us 5 subtract 6 subtract 4. This is 5 subtract 10, which is equal to -5. So you find that our first term is -5, as we have here. Okay, our first term is -5. Let's say you want to find T3. Okay, term on position 3. So we use the same equation. Term 3 is 5 times n represents the position, so that is 3 squared minus 6 times 3 minus 4. Okay, 3 squared, that is a 9, that is a 45, subtract 18, subtract 4. Okay, let's simplify that one. That is 45, 4, 5, subtract 18, subtract 4. See what we can get. Okay, we'll get 23. So we'll get 23. Okay, we want T5 or T6, anything. So T4, and so on and so on. So the importance of the general term is, in case they want to ask us T20, the term on position 20, we are able to calculate that. So it will be 5 times 20 squared minus 6 times 20 minus 4. Then you evaluate, that will give us the term. So that's the meaning of the general term. Now let's get some more examples. We're gonna give it another run. So now we know the background of where these terms are coming from. 2a is equal to 3a plus b is equal to a plus b plus c is equal to so on. These terms, we can have different terms, but the expressions will remain the same. So let's take an example. So let's say we are given a question. I'll take any sequence here. We have got 5. Okay, I've used this one before. 5, 16, 33, and 56, and so on. Now we want to find the general term. The general term is Tn is equal to an squared plus bn plus c. So what would we do? The standard thing to do is to take the differences. 16 minus that one, we get 11, okay? 33, subtract that one, we'll get 17. And 56, subtract, that will give us 23, right? So, is that 23? Yes. And then we do the second difference is 17 minus 11, that is a 6, okay? 23, subtract 17, that will be a 6. So you see the second differences are the same. So now we want to find A, B, and C. So our A, B, and C, let's come to the question now. As we have seen, this second difference is always a 2A, so equate it to 2A. 11 is my 3A plus B, okay? And this 5 is our A plus B plus C, the first term. So now I want to find A, B, and C. I'll work them simultaneously and say, okay, 2A is equal to 6, okay? So our A is 3, okay? And then from there we got our A. I'll come to this first term in my row of first differences. This is a 3A plus B. So 3A plus B is 11, okay? And this will give us 3 times A, 3 plus B is equal to 11. So 9 plus B is 11. So my B is, that will be 2. Okay. And then I go on to the third one, A plus B plus C. So A plus B plus C is a 5. Okay, this term here 5. So that will be A, we got it is a 3, plus B is a 2, plus C is equal to 5. Okay, so this is 5, separate there, so our C is 0. So therefore, what will be my Tn? So my Tn is A is 3, so that will be 3n squared. B is 2 plus 2n plus C, which is 0. So that will give us the general term. Okay, that will give us the general term of the sequence. If you want to test it, you can have your T1. T1 is 3 times 1 squared, I'm substituting here, plus 2 times 1, which will give me 5. Okay, what is my T2? T2 is 3 into 2 squared plus 2 times 2, position 2. Okay, 2 squared, that is a 4, 12 plus a 4, that will give us a 16. Okay, T3, that is a 3 times 3 squared plus 2n, 2 times 3. 3 squared is 9 times 3, 27 plus 6. That will give me 33. So we can create all the numbers, the terms T1, T2, T3, T4. Okay. So my advice is for us to be able to remember these terms. If you can't remember them, you can actually formulate them, okay, figure them out as we have done, as we have explained here. Okay, that's one method that we can use. Another way of working this out. So now let us summarize before I go there. So how do you find the, let's look at the steps that we use now. So steps to determining the general term. Steps to determining the general term of a quadratic sequence. So one, what do you do? Okay, so number one, is to calculate the first and second difference. So that is the first thing that we need to do. Calculate the first and second differences. Okay, in other words, create your row of first differences. This is my first differences here, and the second differences. Okay, and then after that, number 2, the first and second differences will give you the ability to calculate A. Calculate A. Okay, A being the coefficient of the first term. Now, how do we calculate this one? So you always say 2A is equal to second difference. So it's always 2A will be equal to your second difference. Okay, so twice the second difference. That's how you calculate your A. After calculating A, here there are a variety of methods that we use to be able to calculate your other terms B and C. Okay, number 1, I'll take this as number 1. You can do that by substituting 2 terms into the general term, into the general equation. Okay, I haven't explained this one out. That's one way that you can do it. Okay, if I have time, I will take time to explain that one. So that's one way. The one that the method that I'm using now is to say that you need to equate. So you calculate, you solve for B and C, solve for B and C, solve for B and C by, okay, equating. So this is how you equate. You equate, I'll take this one, 3A plus B, you equate it to the first term in your first differences. Okay, and also you equate your A plus B plus C to the first term in your sequence, in your quadratic sequence, that is. Okay, I'm just trying to summarize here. So if you are going to solve for B and C, there are 2 ways of solving for B and C. You can substitute 2 terms into the general equation and you solve simultaneously, or you can use what I'm explaining here is now what I've just been illustrating in the earlier example. Okay, now let's look at some examples now. These are specific examples from previous question papers. So this is a question 2.3, which says that given the quadratic pattern, this is the pattern given, determine the values of x and y. Okay, 2.3.1. okay, this one has nothing to do with what we have explained earlier, but in a sense we do apply the same principle. So what we have here, what we'll do is to take the numbers, write them down. There are 2 marks here, so it shouldn't be much of a hassle. 28, 69, 88, x and y. Okay, what we are going to do is to do the subtraction. 48 minus that one, we'll get 23. Okay, let's subtract again here. 69 subtract 48, that is a 21. Let's subtract again. 88 subtract 69, we are going to get a 19. Okay, 88 subtract 61, yes, 19. Okay, and then when we subtract here, this is now general. X minus 88. Then now this is algebra now. Our difference here will be x minus 88. Okay, and then here it will be, when we do that one, it will be y subtract, okay, x minus 88. Okay, that will be y subtract x. Okay, y subtract x. We are subtracting just the terms here. So this is y subtract the value here. So y subtract x. Now they are asking us to find the values of x and y. Okay. Now one thing that I didn't mention earlier is when you look at the first differences, this row of first differences, these are our first differences. This row of numbers is an arithmetic sequence. In a quadratic sequence, as they've mentioned here, it's a quadratic sequence, quadratic pattern. The first row is always an arithmetic sequence. It's very important to take note of that. It's always an arithmetic sequence. An arithmetic sequence meaning that we are adding a constant term here. Okay, we are adding a constant term. So if I were to find my x minus 88, I would do apply it like this. So now you will find that the difference between this and that, okay, is what we have already. If we were to find the second difference here, let's do like that one. 21 subtract 23, that would be a negative 2. In other words, we are subtracting 2 each time. 23 subtract 2, we get 19, we get 21. Okay, 21 subtract 2, we get 19, and then 19 subtract this one, we get negative 2. Okay, so we always get negative 2, negative 2, negative 2. Now I can use that now to say this number that we are going to get here, x minus 8, if we follow the same pattern, what would be that number? Okay, what would be that number? So that number would be 19 minus 2, which will be a 17. Okay, so which means I can form an equation. I can form an equation and say that x minus 88, it will be equal to 17. There are different dimensions, different ways in which you can work that one out. So you can say, therefore, my x minus 88, this difference here, it should be a 17. Okay, and when you simplify that, that will give us x will be equal to 105. So this number here should be a 105. So that when we say 105 minus 88, we'll get a 17. Okay. Now the same applies, so we got our x is 105. Now the next number that comes here after 17 is a 15. Okay, 17 minus 2. Remember, we are going down, we are subtracting 2, 2, 2. So the next number that comes here it's a 15. So it means if we say y minus x, okay, y minus x, the difference between y and x, it will be a 15. So if I say y minus x, this is equal to 15. Our x is 105, so y minus 105 is equal to 15. Take this one over, so our y will be equal to 120. So our y is 120. That will give us the y value. Okay. Another way, if you don't want to do the subtraction, as you might have noticed here, is to take it like this. Okay, I explained this one in another video. 25, 48, 69, 88, x, and y. Okay, so if you take your differences, we will do the same. That is 23, that is 21, that is 19, right? So that's where it ends there. So we don't know the number that will come here, okay, to get that, and we don't know the number that will come here to get that. So what you will see, like I said, this is a row of arithmetic sequences. This is an arithmetic. So if this is 23, this is 21 minus 2, put in your numbers here. So this one will be 17 and this one will be 15. Now, these numbers, if you take 25 plus that, okay, 25 plus 23, you will see that you will get your 48. 48 plus 21, you will see 69. 69 plus 19, you will get 88. So to get x, we must take 88 plus this number 17 to give us that. So you can say that my x is 88 plus the difference. This difference you have found it from the sequence, plus 17, which will give you 105. Now, so after getting the 105, now I put it here. So 105 plus the 15, that will give us your y. So your y will be 105 plus 15, which will give you the 120. Okay, the next term will be 120 plus 15 minus that one will be a 13, and so on and so on. So that's how you can get the values from there. Okay, so that is the answer to that question. Right. Now let us go to the next part of the question. It says that determine the general term of the quadratic pattern. So this is the question with the most marks there. Determine the general term of the quadratic pattern. So this is what we have been doing now. How do we find the general term? So to find the general term, we have to use this pattern now. We are lucky that we have done it already here. Like we said, first of all, calculate the first difference and the second difference. Okay, remember those steps, first difference and second. So let us do that step. We have done it already. We have got our first difference and our second difference. Remember our general term. Our general term is in the form Tn is equal to an squared plus bn plus c. So we want to find a, b, and c. Okay, so now how do we find our a now? We have found our first difference, second difference. So we'll say 2a will be equal to the first term here, your second difference. That will be negative 2. Solve that one, your a will be equal to negative 1. Right? We want to find the b. What do we use? This term here, if you still remember, that term is a 3a plus b. So this is a 3a plus b. So I'm going to say 3a plus b is 23. Our a is -1, so 3 by -1 plus b. C, I go to this term here, over here, the first term. Remember, I'm equating 3a plus b to t1 here in the first difference, and I'm equating this one, a plus b plus c. This is an a plus b plus c, so I'll go a plus b plus c is 25. Our a is -1, we've calculated here. Our b is 26, we've got it here, plus c, that is a 25. Okay, so calculating c, our c will be equal to, this is 25 now, -1 plus 25, that is 25, comes over, our c will be 0. So what does that mean? It means therefore my Tn will be equal to -1, put it, substitute here, so that will be -n squared plus 26n, b is 26, plus a 0. So that gives us the answer to that. Okay. 233, determine the value of the largest term of this pattern. Determine the value of the largest term of this pattern. Okay, so to answer that question, there are two approaches that we can use. The first one is we can use the differential calculus. Now, when we look at this term, it's a quadratic function. It's a quadratic function. We can write it as t in terms of n is -n squared plus 26n. Okay, if you were to write it, sketch it, it's a concave down. Okay, so that's why the largest value will be the maximum, the turning point. So there are two approaches that we can use. We can take the derivative, in other words, the derivative at the turning point, and equate it to 0. So the derivative at the maximum point is 0. So we are going to derive this function here. When we derive this function, we are going to give a -2n, 2 times -1, that is -2n plus 26 is equal to 0. We are equating to 0. So therefore, solving this one, we get -2n is equal to -26. So our n will be equal to 13. Now, deriving here, it is giving us the position of that term. Okay, so because we are calculating n here, so the n tells us the position of that term. So now we want to find the largest term. What is the term itself? So our term is Tn, so which means our term is T13. So to find the T13 is our largest term. So what is the value of that term? So we are going to use the equation here. So T13 substitute there, that will give us -13 squared, okay, plus 26 by 13 to give us the value there. So put it in a calculator. We are going to have -13 squared plus 26 into 13. Let's multiply by 13. Okay, so the answer will be 169. So 169 will be our largest term. Okay, that answers this part. 3 marks for that. Let's jump into the next question. This is another question, another example. We are just going through the examples now to practice this. So 2, 1, given the quadratic number pattern -16, -16, -12, -4, write down the next term. Okay, So that is 2.1.1. So like we said, the best way is to generate your numbers. Write down your numbers, -12. I always prefer that you write the steps first, the first step first, which means that of subtraction, okay? Write down the differences, your first row, first difference, -16, subtract that one, that will be a 0. Okay, subtract this one again, -12, subtract that one, that is a 4. -4, subtract that one, that is an 8. As you will notice here, we are having 0, 4, so it's a arithmetic sequence. We are adding 4, 4, 4, which means the next term here that we are going to add is a 12. Okay, 8 plus 4. So it means now if we follow the sequence, -16 plus 0, we get that one. -16 plus 4, we get -12. -12 plus 8, negative. So they get the next term, what they are asking here, to get the next term, that will be a -4 plus a 12. That will give us an 8. Okay. So in other words, therefore, our T5, the fifth term, T5 is 8. So that answers that part. Again, this question is to determine the general term of the pattern in the form. Okay, so we have done the first row, so let us find the second row here. Second, 4 minus 0, 4, here 8 minus 4, 4. You can see that this is our row of second differences. Now our general term is Tn is equal to an squared plus bn plus c. So now general term means we are calculating a, b, and c. So let's calculate that one. Tn, actually, let us go straight into finding our a. So how do we find a? A, we equate it to the second difference. So our 2a is 4. Okay, so this gives us a is 2. To find the b, what do we do? Equate this one to 0. This is a, and this is 0 is equivalent to 3a plus b is a 0. Now our a is 2, so 3 times 2 plus b is equal to 0. So our b is -6. Okay, let's find our c. So we go to the next row here. We have a plus b plus c is -16. So a is 2, so that will be 2 minus 6 plus c, that is -16. Okay, so this will give us -4 plus c is -16. That will give us c is -12. So therefore, we can say that our Tn is equal to a is 2, that will be 2n squared, okay, minus 6n minus 12. Okay, so that is our Tn. A, B, and C. Remember, let me put this one in a different color. Remember what I said. We have used the 4, 0, and -16. Should you want to choose to use these ones here, a 4 and a 4 and a -16, these values that we are using, 3a plus b and the a plus b, they will change. Okay, so actually you will now be using, you will now be saying this is remains 2a, so you will say 2a is equal to 4, our a is 2, it will remain 2. But if you are going to use this 4 here, not the 0, the second term in your first row, in your a row of first differences. So this one is not a 3a plus b like we have mentioned here. Now this one is, if you still remember, this one is a 5a plus b. So this one is a 5a plus b. So you would say 5a plus b is equal to 4. Okay, our a is 2, so we are going to have 5 into 2 plus b is equal to 4. So you have here 10 plus b is 4. So you get your b being equal to 4 minus 10, which is negative 6. Okay, so you get the same answer here. And if you're to use negative 16 is not an a plus, this is an a plus b plus c, but this one here is a, if you still remember, that is a 4a plus 2b plus c. Okay, so you would go and say, okay, to answer that one, 4a plus 2b plus c is equal to this term here, negative 16. So you equate it to negative 16. Okay, and 4a, we got our a is 2, so 4 into 2 plus 2b is negative 6 plus c is negative 16. So the difference is just that you are now working with the bigger numbers. So this is 8 minus 12 plus c is equal to negative 16. Okay, that will give us 8 minus 12, that is a negative 4, plus c, which will give us negative 16. Take 4 to that side, our c will be negative 12. So you will get your Tn being a 2n squared minus 6n minus 12, which is the same answer as that, but we used different terms. So I just want you to be aware of that. Another way of finding a, b, and c, if you don't want to use this, okay, 3a plus b is equal to 0, and a plus b plus c is equal to negative 6, which I suggest you must practice that, because it's actually a shorter method than what we are going to work on now. So the other approach that you can use is to take your, we now got our a as 2. So we will take your equation Tn is equal to, now we know our a, the general term here, our a is 2. So you write that as 2n squared plus bn plus c. Okay, so that's what it means. So now, what it means now, we are going to substitute, take any two terms, okay, and substitute them in. Let's say I'm going to take negative 16 and negative 16. Okay, any two, or you can take negative 16 and this 8 here, any two terms, you substitute here. Now, so I'm going to say Tn is my negative 16, but this negative 16 is a T1. Okay, so in other words, my n is going to be 1, 1. So I'm going to have, what is my Tn? It's negative 16. This is equal to 2. The position of that negative 16 is a 1, so I'll put 1 here, squared, plus b times 1 plus c. So you find that you are going to get an equation which you are going to solve. Let's simplify that one. Negative 16 is equal to 2 plus b plus c. So it means the b plus c will give us negative 18. I'll call that equation 1. Okay, so I have used the T1 here. Okay, what is my T2? Our T2, I guess, is the same value, 16. Okay, the difference now is I'm going to substitute, my n is going to be 2. So what is my T2? So substitute again, negative 16 is equal to 2 into my n now is position 2. Remember, n is position, so that will be 2 squared plus 2 times b times 2. That will be 2b plus a c. Okay, that will give us negative 16 is equal to, this is 4 times 2, that is 8, okay, plus 2b plus c. If you simplify this, you get 2b plus c will give us negative 24. So that is our second equation. We are going to solve simultaneous. Remember, a, we got it already, so we are now finding a and b. So I'm now going to solve that one. I will write the equations. 2b plus c is negative 24. But b plus c is negative 18. So b plus c is negative 18. I've written those two equations. Now, we can use the method of elimination here. Okay, elimination, either subtract this equation, subtract that one. So it will be 2b subtract b, that will be b. We are eliminating a c, c minus c, that will be gone. Then negative 24 subtract negative 18, that will be a negative 6. So you get your b is 6. Now negative 6. So when you get your b, so put substitute it in one of the equation. I'll use this one here. So I'm gonna say negative 6, that is my b now, we just got it, plus c is negative 18. So our c will be negative 18 plus 6, which is negative 12. So we got now, therefore, our a, we got it as 2, our b, we got it as negative 6, and our c, we got it as negative 12, which gives us still the same values that we got earlier here, negative 6 and negative 12. So another way of doing it is to substitute, take any two terms that you get, substitute them in the equation, and substitute it in your general equation. You get two equations that you are going to substitute, that you are going to solve simultaneously. Okay, I'm not interested in that method now, but the one, that method which is my favorite, is to approach the question with what we have, what I've just explained here. 3a plus b is equal to 0, and so on. Right. So I hope you learned something from this tutorial. Give your comments. Here is another example that you have. You can have a look at it. Okay. And work it out. Take a pause and just work it out. You'd say that the quadratic pattern, we are given the quadratic pattern here is 86, 119, 150. Write down the next two terms. Okay. And that is first question. This is what we have been practicing. Determine Tn, the general term of the pattern, in the form that one, and which term of the pattern has a value that. So try to work out those questions. Okay. Thank you for watching. I hope you learned something. We'll see you in the next tutorial. Okay, like and give your comments below, and we'll keep in touch. Bye.